Okay, welcome everyone in our series of webinars on large language models. Today, I have my guest. We have Alicia Krishnik from Y Labs, and we are going to talk about observability of large language models. Welcome to the webinar, Alicia. Do you want to go ahead and introduce yourself?
Absolutely. Hi, Raja. Really great to be here and excited to talk about everybody's favorite topic, which is LLMs, and my favorite topic, which is observability. So my name is Alicia Krishnik. I am the CEO and co-founder of Y Labs. Y Labs is an AI observability company. My specialty is building tools that power a more robust and responsible AI adoption. I have been focused on the abundance of problems of AI operations for the past decade. My favorite space in the kind of AI operations tool chain is, of course, observability. Prior to Y Labs, I was a CTO in residence at the Allen Institute for Artificial Intelligence, which is a fundamental AI research institute and the birthplace of Elmo. At the Allen Institute, I evaluated commercial viability for various AI operational tools, including explainability and fairness, which were the most hot topics back in 2017, 2018 time. Before the Allen Institute, I spent 9 years at Amazon leading various AI initiatives, including leading the development of the initial AI operations platform, or back then we called them machine learning platforms, as well as working on the early SageMaker. And at Y Labs, we specialize, of course, on observability of AI applications, and we'll unpack what observability means throughout this discussion. But specifically, our platform provides solutions for large language models, traditional models, massive scales of data pipelines that, in the end of the day, power AI models. And the solutions that we provide help enterprises make sure that these models and these AI applications are running reliably, responsibly, and deliver high quality outputs.
Okay, thanks for the introduction, Alyssa. So let's get started, right? So, and maybe a personal question, and many people that I've talked to, they also have this question. So we had MLOps until a few years ago. Then we now start talking about LLM ops, and now there is observability as well. So can you explain this for someone who's not really, they understand the general space, maybe they understand DevOps, but like what is the distinction, and how do I understand what is what?
Excellent starting point. So I would actually begin with DevOps, because that's probably the most kind of common denominator across all of these activities. And DevOps is very simple. Everybody's familiar with the continuous integration, continuous deployment concepts, which are powered by a set of tools, which we call developer tools, which enable operations of software. So, you build software, you deploy it to production, and then what happens? Well, hopefully everything runs smoothly, potentially not. How do you ensure that everything runs smoothly? How do you ensure that you have a way of rolling back your production deployment? How do you make sure that your production deployment runs at a certain latency? How do you make sure that your production deployment actually delivers the features that you wanted to deploy? All of these activities that involve kind of post-production operations typically fall under the DevOps umbrella. Now, with the proliferation of AI models into software applications, the concept of MLOps was created. And MLOps is, I think, very much inspired by DevOps and very adjacent to DevOps. Specifically, it extends the DevOps activities to AI-specific things. So potentially some aspects of the deployment are different. The model gets trained, then the model gets packaged and potentially gets deployed behind an API. And from there, we spend time evaluating and making sure that the model behaves as we expect in production, because the model is trained on some data that was available in the past during the model training and building phase. And now that the model is in production, the model is seeing the data that it has never seen before. And a lot of the MLOps is spent, a lot of the MLOps activities are focused on making sure that, the model generalizes well to this new data, that the model performs well for all segments of customers, that it doesn't discriminate, and the performance of this model is on par with what was discovered in evaluation, what was calculated in the evaluation phase. So that's MLOps, and that covers, every single model that under the sun, everything from, your very boring logistic regressions to your more fun deep learning models. And I guess now comes 2023, ChatGPT is out, LLMs are all the rage, and we have this new concept, which is called LLM ops, which is, again, super adjacent to MLOps. It means all of the same things, except for large language models. I would say there are a few fundamental things that are different about large language models from the traditional machine learning AI models. Specifically, unless you train the LLM yourself, which is very rare, you do not have access to the training data. So that changes quite a bit of, how you can understand how the model performs. Experimentation is done differently in LLMs from traditional models because you spend time doing prompt engineering, which is a concept that is kind of unique to LLMs. And you also do fine-tuning, but fine-tuning is a shared activity between traditional ML models and LLMs. Evaluation is done differently because in traditional machine learning models, you have some kind of validation set that you evaluate the model on before putting it into production. In case of LLMs, when you're using foundation models, they're benchmarked, but evaluation for how it generalizes to your specific use case is typically done using like A/B testing. So there are a range of things that are different in LLMs, which is why I think we have the new term that kind of describes all of these activities of what happens with large language models in production.
And so I think someone also asked this question. So how does observability tie in then, right? So you explained the whole thing. So, is LLM ops observability, or there's something else beyond that?
Fantastic. Thank you for the question. So LLM ops encompasses all the activities, evaluation, fine-tuning, prompt engineering, observability, under one umbrella. So it's all the activities that you do to make sure that your model runs in production. Observability specifically is about understanding how well your model works. So observability as a concept comes from control theory, and it simply means that you are able to understand the behavior of your system, internal behavior of your system from the outputs that the system generates. So when you have a large language model, typically it comes in the form of an API, and everything is kind of black box from there, right? And observability is a process and a property essentially of the system that helps you understand how well it works. I'll get more specific. So for example, you have a large language model, potentially it's as simple as the OpenAI's API, and you are trying to understand whether this model is running and performing well for your specific use case. Let's say it's a simple summarization task that you're trying to enable in your application. So let's say you have an application for helping people write emails, and with the body of an email, you generate a subject. So here you are using an LLM, and you need to make sure that the outputs of this LLM are kind of relevant and on par with what you want this application's behavior to be. So you would essentially collect various signals that describe the behavior of this LLM enabled application in production. Things like how long of a email subject does it typically generate? What's the readability grade level? So is it very simple fifth grader type of sentences that it uses in the email subject, or is it like very complex academic sentences? You would potentially measure toxicity. You would measure whether the the shape of the output is a simple sentence, which is what you want for an email subject to be. So all of these different signals that help you assess whether the output of this LLM is suitable for your application continuously as you're generating different email subjects, as all of your users from all of the different countries are generating different email subjects. And observability allows you to kind of understand that on the grand scheme of things, continuously monitoring, continuously gathering these signals and flagging when some of the signals are out of whack.
Mm-hmm. Okay, so let's drill down on this this idea. So when I go back to LLM ops, so let's say I have a model, I'm optimizing the model on precision or recall or accuracy. I have some metric. So I can clearly build a dashboard on a benchmark data set, right? And you made a passing remark just maybe a few minutes ago that we don't have that luxury in large language models. Can you elaborate a little bit? I mean, why can't we benchmark large language models that easily?
Well, so we can and we can't. When it comes to large language models, because they come in the shape of foundation models, so they're trained to be good across a wide range of tasks, right? Which is fundamentally different from our traditional machine learning models, where traditional machine learning model is for example, topic extraction. So like this model is very good at extracting topics. That's like its sole purpose. And then you can evaluate it across a range of metrics. When it comes to large language models, they can extract topics, summarize text, they can generate text. There is a wide range of tasks that they perform. So evaluation is kind of split, I would say, into two sets of activities. One is the benchmarks that the creators of the models publish. And there are a range of kind of widely agreed benchmarks in the community that benchmark these large language models and give practitioners or, somebody who's looking to adopt one of these large language models in their organization, they give them a sense of like, okay, how does a Cohere model perform compared to GPT 3.5, for example? And those are benchmarks that I would say just directionally give you a sense of how good this model is. From there, once you decide and figure out which use case you're going to be using this model for, that's kind of where the second phase of evaluation begins, because you have a very particular task. So let's say, going back to my example, we're talking about summarization. You kind of constrained what this model should be good at because you only care about the use case of suggesting an email subject. And there you can do kind of a second round of evaluation where, given continuous kind of prompts that your user generates when they interact with this application, you can calculate like a blue score, a rogue score that specifically measures the quality of summarization. And then you can calculate a whole bunch of other, I would say, trailing indicators and leading indicators that show you whether or not this model works well. For example, you can calculate things like reading level, which I was mentioning, which indicates, are these subjects readable or not. You can, do various very simple things like word count, sentence count, and then you can do more complex things like relevance. So measuring the distance in the embedding space between the email body and the email subject that the model has generated to make sure that the subjects that the model generates are relevant. And then on top of that, you can also track things like, is the user accepting the subject that the model generated? How many words have they changed in the subject, in the auto-generated subject before accepting it? And then you can also segment the users and say, okay, are the users in Spain accepting as many suggestions as the users in the United States? And that could give you a sense of, okay, is this model doing well in Spanish versus English? So all of these signals that you gather to get a sense of how well your model is working in the wild and production, kind of continuously evaluating it. All these signals are observability signals.
Okay, so this is great. So I build LLM applications. I don't build them, my team does it, but, I understand how things are built. At what point should I decide that now here is the time? I need an observability tool, right? So should it be integrated right from the beginning, or is there a point in time? And so, are there any recommendations?
Yes. And I mean, I'm a bit biased, I guess, because I run an observability company, right? So I think from the best practice perspective, the earlier the better. And it doesn't have to be, you don't have to kind of go all in and say, okay, now I'm going to go get a very sophisticated observability platform and like measure everything from the very moment that I choose what LLM I'm using. I would say instead you should start small with things that make sense. And observability fundamentally enables you to understand how well the model works, and hopefully you start with this understanding from the very beginning, right? So I would say when you're prompt engineering, right, you're fundamentally with kind of every set of prompt engineering exercises, you change how the LLM behaves and how it will behave in the application that you're preparing it to power. And it's very hard to track changes, for example, when you're doing prompt engineering. It's not as version controlled. It's really hard to measure the consistency of behavior. And it's probably prompt engineering is kind of this new activity which we haven't dealt with before in traditional models. And it's really hard to make sure that once you're done with your prompt engineering exercise that potentially makes some aspect of your model work really well, it's really hard to make sure that other aspects of your model didn't stop working well after this exercise, right? So that's probably the first place where observability comes in. A very common things that our users do, and we have an open source package called Langkit, stands for Language Toolkit, for enabling observability in large language models. And it's a very lightweight open source package. What you do is essentially you put all your prompts and responses through it, and you collect various signals that are kind of consistently measuring how your LLM is working. And the easy thing to do is potentially to define a super simple policy. Okay, here are my 50 prompts that I want to run through my LLM every time I do a prompt engineering exercise. You run these 50 prompts through your LLM, you measure a lot of different signals about the responses, and then that becomes your baseline. Every time you run a prompt engineering exercise, you should run through the same exercise and see whether some signals have changed and how your LLM behaves now. That's a very simple exercise. It doesn't require any complex setup. It's essentially standardizing. It's a process of standardizing on what you're measuring to assess the quality of your LLM behavior and doing it in like systematic, organized way. And that could be done like way before you're in production, when you are essentially designing this application that the LLM will power.
Yeah. So for those in the audience, right? So we are used to having this train test validation split in data. Having a separate data set, call it holdout data set, right? So we build the model, do our parameter tuning and all of that cross validation, and then we go and test it out if the model is still accurate or not. How do you do this in the context of a large language model? I mean, how do you come up with that validation set for your data? Because now there is nothing that you can do about it, right? And even if my model's response let's take this example, right? I made a minor change in my prompt. Okay, maybe I added more documents if I'm using a RAG implementation, right? So I have retrieval augmented model or retrieval augmented application, or maybe I fine-tuned my model on new data. Just I did something, right? And my model is perhaps it is better, perhaps it is worse, right? So in a machine learning setting, I have this validation set to go and validate on. What do I do in case of an LLM application?
Indeed, it becomes very, I would say not a lot harder, but it becomes different and probably a little harder. There are a handful of things you can do. So the simple thing you can do, and that's very, very kind of common, I would say best practice that that is accessible to everyone, and that is generating like a range of, so asking the model the same prompt, and then asking, if you're working with OpenAI models, you can essentially ask the model to rate its own response. And on a range of prompts that you have collected, you can essentially gauge the score that's associated with the quality of the response by just collecting the scores for every response generated by the OpenAI model when you're essentially ask it to evaluate itself. That is probably the simplest thing that you could do. And it involves establishing a few things. One, it involves, hopefully picking the model that allows the self-evaluation. And I think currently OpenAI models are the ones that notoriously do this and are used very widely for evaluation. The second thing is figuring out your prompts. So which prompts would be sufficient to essentially feed into the model to gather these evaluations. And collecting these prompts probably is a part of the very early application design process, right? So you're trying to essentially describe what your application should be good at responding to, and these would be the prompts. So collecting these prompts and potentially making sure that as you're discovering new use cases, these prompts represent these use cases, and then having a mechanism for feeding these prompts through the LLM for the self-evaluation. That's the simplest thing to do. The more complex thing to do is, in addition to that, because once you do the self-evaluation, the only thing that in the end of this exercise is the average self-evaluation score the same, better, or worse? But it doesn't tell you materially why is it better, how did these things change. And to achieve kind of better visibility into how your model works and how have your RAG exercise have changed the behavior, extracting additional signals from the response. So extracting, and it depends on the use case. Again, extracting relevance to response relevance to prompt, for example, and that's where embeddings come in. You essentially embed prompt and the response into the same embedding space, and you calculate the distances. That's one exercise you can do. Another exercise you can do is extract various metrics. So if you're worried, for example, that your model is I don't know, you have some application where potentially any user can interact and you're worried about like sentiment or toxic behavior, you can extract, and you're trying to like fine tune or RAG the model to make sure that it doesn't return these low sentiment or toxic responses. That's where you would continuously measure the toxicity or the sentiment of the responses. If you're worried about security, for example, and you're worried that your model could be jailbroken, or you're worried about prompt injections, you essentially collect the prompts that represent prompt injections, and you see whether your model actually responds, and you track that as metrics. So that augments the self-evaluation exercise with metrics that is more understandable by the human, right? Who is operating and evaluating this model. Is this model becoming more toxic, less toxic? Is this model becoming more prone to prompt engineering or less prone to prompt engineering, and so on?
Okay, so you mentioned these prompts that could be the intent could be for jailbreaking, or they are toxic prompts. So any observability tool, let's say talk about Y-Labs here, do they come in with a set of these prompts that you can actually use, and some standard well-known toxic or malicious prompts that you will be running on your model, and then see if the model gives in to those prompts?
Yes, we definitely give you kind of a very simple baseline of the types of prompts that you can try. But typically these prompts are very specific to the application. So the users bring them over from kind of their experience of evaluation. When it comes to prompt injections and jailbreaks, there are databases that we help you hook up to. So you don't have to, build your own database of the common kind of flaws, security flaws in these models.
Mm-hmm.
So for those, that's a little bit easier. We make it super straightforward to hook up to like a jailbreak database, a known jailbreak database. And that gives you, some peace of mind that your model doesn't respond to known jailbreaks. And then as far as kind of toxic prompts, relevance to your common responses, that comes from the user-specific case that they bring in. Typically, what we see done a lot is when as the model is being developed, fine-tuned, and improved, there are a set of things that are done more or less manually to kind of spot check whether the model still works. There are kind of these similar to how I think QA works in most cases, quality assurance, where you have like manual test cases that you gather. I think these prompts are becoming similar to these manual test case exercises. So the developer of the model knows, okay, these are like 10, 20 things that the model should do well. And I typically run through these prompts every time when I make changes. And these prompts become kind of the foundation of this exercise of continuous evaluation and observability. And I think the key here is being organized about these prompts. It's like we have in data science, we have like the golden data set. This becomes like your golden prompt set. Keeping organized with these prompts and making sure that they reflect your desired kind of model use cases is key. And then running through them kind of in a more systematic way. So not just spot checking them by hand, by having a way to automate it every time you make changes, I think is also key.
Okay. So far, what I understand is what we are discussing, it's mostly in the training pipeline, as we call it, right? So training and evaluation pipeline. But what about during, once the model has been operationalized, it is deployed now, how do I detect, is it possible in any of the platforms that I can, if someone is trying to jailbreak, or if someone is, or perhaps not, I mean, there is a prompt side of it and there is a response side of it, right? And both could go wrong. I mean, large language models, they can have unpredictable behavior, right? Even for the same prompt. So because of some minor change, right? So the smallest change in the system, it can result in very different responses from LLMs. So does an observability tool help us detect any kind of response drift or maybe response instability?
Yes. And I like how I like this question because it touches on this response drift, response instability, like response is bad. Or, when we don't like the model responses, we typically call them hallucinations because that's another very popular word of like, okay, I don't like the way my model is responding. It's hallucinating. That's not good. So yes, I wish we, as a community, I wish we had better terms for this, but essentially the main activity once your model is running in production, aside from managing costs, becomes making sure that your model is generating responses that are on par with what you would expect and power customer experience in a positive way. And in this, once you're in production, the activity becomes scanning your prompts and your responses and extracting insights from both and these insights would kind of give you an indicator, again, leading indicator, trailing indicator of whether something is going wrong in your application. And the types of insights you would be extracting from both prompts and responses should be similar to the insights you were extracting during evaluation. Like if you were making sure that your model doesn't converge in some kind of toxic and some kind of toxic loop, and you were stress testing it for toxicity, you should be doing that in production as well. So you should be assessing the toxicity of the responses. And again, I think the key here is making it super easy to do, which is what we've invested with Linkit Essentially, you can use, your favorite Hugging Face model or your favorite model that is available internally at the enterprise. Pretty much every enterprise that has reviews has a toxicity model that they have trained, and you just continuously check the responses, making sure that the toxicity of them doesn't cross whatever boundary you have defined with your policy, for example. Some of the most, I would say, sensitive things to make sure when your LLM is in production is things like data leakage or PII leakage, right? Because one of the key reasons why somebody would try to jailbreak or prompt inject your model is to retrieve potential PII from there. So monitoring both prompts and responses for prompts for PII leakage and responses for PII leakage to make sure that PII is not coming out into potentially undesired, to not becoming available to users who do not have access to it. That's a key activity to do. And then monitoring the model to make sure that I brought it up a few times already, that the responses are relevant to the prompts. So effectively, the exercise once you're in production is extracting the same insights that are relevant to your model's performance during evaluation phase. You're extracting the same insights, but now from your live prompts and responses, and you can use the insights and kind of the thresholds of these insights from the evaluation phase. You can use that as a baseline for your production. And in production, now you're saying, okay, my model has never gone into a negative sentiment. I need to make sure that in production, I do not have any responses with negative sentiment. And if I do, I can flag them, I can guardrail them. There are a few things that you can kind of do to handle the behavior. And then, of course, you're running potentially continuous evaluation if you do have some kind of human labeling exercise. And if you don't have, this continuous, if you don't have access to some kind of continuous evaluation pipeline because you don't have ground truth, one thing you could do actively is measure how well the users are interacting with the LLM. So back to the example I gave a bit ago about summarization, you essentially gather signal on whether the user accepts the suggestion that the model has done, how much do they change the suggestion, do they just opt out from the whole experience? Because in the end of the day, no matter how good the model is, if the user is not interacting with the model-powered experience, there's either something wrong with the model or maybe something wrong with the application altogether. That's probably the best indicator that your model doesn't work, or the application that kind of wraps the model doesn't work. And that's absolutely key to track.
Okay, that's great. So you in earlier in the discussion, you mentioned designing of experiments, and then now we are talking about, well, the proof of a model being good is, well, the user is interacting. So, can you really design an experiment? Can we do a classic A/B test on an LLM application? Because control is so critical to when you're designing an A/B experiment, right? So, and then now here, how do you control or is it based on user behavior or how the users are interacting? So I would like to hear from you.
Yeah, in my opinion, it's whether there's an LLM or a machine learning model or some kind of very simple heuristic, it's still software and it's still all about the user experience. And we're still working on providing some kind of user experience that is useful, valuable, and potentially, hopefully, delightful and safe. So measuring whether the user interacts with the output is absolutely key and absolutely critical. I would say if you measure anything at all, you should measure that, because that could give you a sense of, again, is this model good or not? Is this model generalizing to geographies and languages that I care about? Is this model generalizing to potential customer segments that I care about? Is this model, is the experience that this model powering, is it as useful to the the young users of my website versus the older users of my website. So you're essentially measuring that and making sure that as you measure how the users interact with your model-powered experience, you have the right segments and the right cohorts identified to give you a signal of whether this model just doesn't work well with certain types of users, is the most important activity, because it gives you visibility into how useful and for who this model is. And it also gives you visibility into, is this model biased? Is this model essentially discriminating the user experience that I'm building? And these are the most key activities. And from there on, we need to focus on making sure that this model doesn't leak data, that this model doesn't allow abuse and so on. But measuring the user experience, I would say, is key. And that's where A/B test comes in. Again, nothing new, nothing, super groundbreaking, the good old boring A/B test that you set up to make sure that, the color of the buy button on your website works well. Similar experience should be set up when you're running these LLM powered experiences. Is the output of the model, if we're talking about summarization, for example, which is probably the most common use case that I see successfully deployed to production. There, you could just, suggest the email subject, or you can also add a few buttons that give you a sense of, is this output useful or not useful? You could, have a button that helps the user report whether the model, returns something offensive or something completely irrelevant, and so on and so forth. So they're different depending on the use case, depending on the environment. There are different things that you can try, but I think the goal is to converge on the user experience, where hopefully this model is not kind of aside, if you're not building like a ChatGPT replacement where the model is the center of the experience, right? In most cases, the model is hopefully this like invisible magic that powers this awesome experience. And experience itself, the way you build it, the way you serve the model responses, I think spending time A/B testing and making sure that you know what you want to measure, which is the boring things, again, like convergence of your users or time on app, is still the best way to measure how well the model works for your particular use case.
So you're basically saying that you will still do that good old A/B testing around user experience and business metrics, right? So if
absolutely.
Okay.
If not, I would actually spend more time doing that, because I think when it comes to LLMs, again, they are fundamentally, they're different from our traditional models, because traditional models are built to perform a certain task well. So that, if this model's in production, it should perform the task well, because you spend time evaluating it. I mean, you spend time gathering data, training the model, and evaluating the model to perform this task well. Now you have the LLM, which performs all kinds of tasks pretty well, better than most traditional ML tasks, but it could, because it performs all of these different tasks fairly well, it is much harder to ensure that it performs your specific task very well on all of the different scenarios that you care about. So there, continuously measuring, I think, is absolutely key.
Okay. That's great. So we have a few questions on here in Q&A. Let me actually, question by Jason. Let me go backwards here. How does an observability platform contribute to collecting training data that can be used to further refine or fine-tune or improve a suite of models? Can you say more about PII filtering? Does YLab have features? I think these are two questions.
Lots of questions.
Yeah, lots of questions, right? So first of all, I think it's more about, looks like it is maybe more of a relevance or, implicit feedback, contribute to collecting training data that can be used to further fine-tune and improve a suite of models. I mean, so yeah, does a observability platform, does it have it built in usually? Or maybe YLabs, does it have it?
Yes. So one benefit of enabling observability and continuously essentially tracking the behavior of your model is you can flag prompts and responses or prompt response pairs that fail particular policy. So let's say we go back to relevance, and if you're continuously monitoring the relevance of response to prompt, you can and now as you're monitoring, you start identifying edge cases where the relevance is just as very different from majority of your prompts and responses. You flag those, and those become your edge cases from the wild, from production environment, that you can then, as you're tweaking the model and making sure that it works for these relevance edge cases, you can as you make changes, you can run through those pairs of prompts and responses, or rather, you can run through the prompts. You can see whether the responses are now different after a fine-tuning exercise, and whether the relevance has improved compared to the responses that you have seen, that you have collected. So that is one kind of very fundamental exercise that the observability platform allows you to, continuously run, is collect these edge cases from the real-world interactions between the model and your users. Okay. And you use those newly identified prompt response pairs to then build out your test set, your evaluation set.
Okay, yeah, this is great. And I think the second part, or the second question by Jason, was, can you say more about PII filtering? Does YLabs have features like this? For example, anonymizing user data prior to fine-tuning or training?
Yes. So I want to make sure I kind of draw the boundaries between what we do and what you can do. So first of all, as far as PII goes, what we make super easy at YLabs is detecting whether there is a PII, in either the prompt or the response. And once you have detected that, it is up to the user what you would like to do with it. So in some cases, if you, let's say, detected a social security number, your policy is, I don't know what else is in that response. I don't want to show that response to the user because clearly there's something went wrong and there shouldn't be a social security number in this response. So the action would be not anonymizing, but just to essentially block this response and return a canned response. This is a kind of one of the scenarios that we would help the users with. Essentially, we would sit between, we have a container that we can help you deploy that sits between essentially the final model API and your user. And then if the response comes in that doesn't pass some aspect of your policy, for example, it has a social security number, you can choose to say, okay, in this case, I want to, in the case of PII policy violation, I want to return some kind of canned response, like, sorry, this ask the question again, or something along these lines. Now, as far as PII and the prompts, a similar approach. You can continuously watch prompts for PII, and if you have a particular type of PII that is in the prompt, you can return a canned response without even going into the model to the user saying, okay, according to our company policy, you should not be sending any kind of PII to this model. And then as far as anonymization goes, that's a hard word. Again, that's a behavior that the user can choose to do. So for example, if you say, instead of just blocking the response, I want to anonymize, or instead of blocking the prompt, I want to anonymize and essentially just X out all of the things that look like PII. We make it easy to recognize that there's PII, and then we make it easy for you to essentially take one of the very popular anonymization libraries or anonymization services and just plug into that and use that to anonymize either the prompt or the response before it makes it to the model, or the response before it makes it to the user.
Okay, so in a so you made a very interesting point, because I mean, when you hear the word observability or monitoring, it almost I mean, one could think that it is more it's more reactive, right? So you're just telling me that something might happen. What you just told me is that you're sitting between the prompt and the response layer, and you're basically, if the response is something that's against your policy, an observability tool can actually can suppress that response and come back with a canned answer. Hey, this the response was against the policy, and then it just suppresses it. Is that if I understood that correctly?
Yes. So it does. I mean, it's still within the capabilities of observability, of the observability tool, at least from our perspective at YLabs, because observability, kind of in the traditional sense, as you said, it could be kind of a post hoc or perceived as a passive activity. But in the end of the day, it's not, if you find out that you have PII leakage, even like 5 minutes after the PII leakage happened, it's too late. I mean, it's great to know. Maybe you can do something about it.
It is on
do some
Twitter already, right? So you have a big
Yes.
business and it is already in Twitter, right? So
Yeah. So from where we stand at YLabs, what's important is helping the user, helping the LLM operator understand the behavior of the model based on, so extract, we make it super easy to extract various signal from both prompts and responses to understand the behavior of the model in real time. And then the next step from there is giving the user, giving the LLM operator the infrastructure that makes it super easy to decide what action you would take when you see something, right? It's like the good old see something, say something on the bus, right? A similar technique, like if we just notify you, who knows when you would have the opportunity to go and tackle this problem, because everybody's very busy. So to take a step further, I think closing the loop and helping the operator react to a particular behavior that they are monitoring for is absolutely essential. So we take that further step and we essentially provide infrastructure within this container, like think of it as like a reverse proxy container that allows you to take a step further and define what types of actions you would like to take if a certain policy is violated.
Okay, that's great. So let me go to another question here. There's a question by Crispin, and I will let you decide. I'm not sure if I completely understand, but how does observability interact with contextual learning, embedding, or fine tuning? And then follow up is additionally audit or governance chains. I sort of understand, but I will let you decide. Yeah, you can see the questions, Alyssa, right?
Yes. So I can kind of go back to our earlier discussion, which we had on evaluation. So how does observability relate to evaluation? How does observability relate? And I think an extension of that is how does observability relate to fine-tuning and embedding? So contextual learning, embedding, fine-tuning, let's just put that all under one umbrella. And I hope I'm going in the right direction. Crispin, let me know. But it's under the umbrella of tuning the model behavior to make sure that it works well for your particular for the particular task that you would like to use it for. And similar to our discussion on evaluation, when you make these changes to the model, when you fine-tune the model, when you essentially embed it to make sure there's you use your favorite vector database to enable like a RAG retrieval, you're making changes to how the end user experience or how the end behavior of this model. You are making changes to the end behavior of this model, and you want to continuously evaluate whether that changed behavior is still on par with what you're trying to accomplish, right? So it goes back to that idea of having a set of prompts that you believe describe your use case really well, that kind of play out all of the most common activities. That's one way of doing it. So having that set of prompts that you can run through your model once you have done contextual learning or fine-tuning, and seeing whether the responses from the model are still on par with what you have expected or what you have seen previously, or things have gotten better or worse. That kind of gives you that indicator. And then when you are in production with this newly fine-tuned model, running A/B tests, it becomes key. And their observability is the exercise of collecting the signal so you can compare the A to the B and whether the fine-tuned model performs better on a bunch of signal compared to the not fine-tuned model. So observability, essentially, what observability makes easy is defining and extracting the signals that then would help you understand whether your model is behaving better or worse.
Okay, this is great. And then I think there is one question specifically, maybe you're the best person to answer this. Are feature-rich observability tools available for pre-seed indie developers, or do most observability tools have pricing models that target more mature enterprises?
So in case of Y Labs, and let's start with that. So in case of Y Labs, we have a free tier where indie developers can go and instrument the LLMs that they're running without essentially paying anything. From my perspective, it's extremely important to make these observability tools accessible to everyone, not just mature enterprises, because in the end of the day, the applications that we build as indie developers, as hobbyists even, impact the lives of people, impact everybody from our kids to our grandmas on the internet. So making sure that the simple best practices of observability are accessible is absolutely key to me and to our mission at Y Labs. And for that, we have a free tier in the platform. You can monitor and continuously observe 2 models, 2 LLMs. And once you kind of mature into more models, more use cases, you can upgrade to the next tier, which is an expert tier, which is also super, super accessible. And as far as enterprises, that's of course a different discussion. But yes, feature-rich observability tools are available for pre-seed indie developers, and observability should be an activity that you incorporate into your machine learning team's culture and process from day one.
And Y Labs also has an open source package, right, to begin with, right? So it's
yes.
Okay.
Yes. So the Linked library, which I believe has been shared in chat, that is the library that there's completely open source, and it allows you to start with this discipline of extracting consistent signal from your LLM behavior, from both prompts and responses, to understand, how is the behavior of your model changing over time. And then the platform itself, think of it as kind of the next step. What the platform allows you to do is organize all of these signals that you're extracting continuously, set up monitoring, set up benchmarks, notifications, all of the kind of things that are in the spirit of automation of these activities are enabled in the platform. And the platform is available in a free tier and an expert tier, so super accessible to all the developers.
Great. So, Alyssa, are there any horror stories of not using observability tools and deploying an LLM application? We are quite early, right? So everyone is trying to figure out what to do. But are there any interesting, maybe from a classic MLOps standpoint, any explainability or observability horror stories that, why should I care? Why should I pay one more company, or why should I bother my engineering with having one more thing to do?
Of course there are horror stories. The most classic language model horror story, I guess her name, I don't know what's the proper pronoun, is Tay from Microsoft, that was launched in Twitter, I think
2016, right?
2016, yes. And it became toxic very, very, very fast, became dangerous very, very fast. And, it was brought down. So how could observability help in such a scenario? You would get very early indicators that the model has toxic behavior before it's obvious to everyone, right? And this goes back to this very nerdy joke that I make, that if you have a software application in production and you're not monitoring it, guess who's monitoring it? Your customers, Because if you don't have some kind of signal that would tell you your application is not doing well, something is broken, then you're going to learn about it when you get an email from your customer or when you get a ticket open. Hey, this is not working. And, it's okay if, hey, this is not working, I get a 404. That sucks. Hey, this thing in your application is spewing toxic, racist content. That is massive, massive liability. In fact, that's one of the challenges with AI applications. They make a lot of decisions. They make large volumes of decisions, right? That's why everybody wants to have an AI application in various aspects of their business, because before a decision is made by a human or by a set of kind of heuristics, and the quality of this decision and how many decisions can you make per minute is very bound, right, by the capabilities of heuristics and humans. With machine learning model, let's say you're trying to categorize things, right? If before you would probably use some kind of very brittle set of, Excel or SQL exercises. Now you have a model, it does it really fast. It could categorize a million things in just a few seconds. And now essentially, if something is broken in this model, you miscategorized a million things in a few seconds, or 500,000 of those things have been miscategorized. And the impact of that on the business is big. Now with LLMs, I'll take it a step further. Think of an LLM as an intern, right? And there are two types of interns. There are interns who, do a lot of the tasks really well. And when they don't know how to do some kind of task, they come in and they say, I don't know how to do it. Help me, let's talk about it. And then there are interns who don't know how to do some kind of task and they fake it. So LLM is your intern that fakes it all the time. By design, that's a probabilistic model. This is how it works. It doesn't tell you that it doesn't know. So essentially, when you have a bunch of LLMs throughout your organization that are doing things, think of them as interns who never tell you that they don't know what to do. And it's like suddenly your organization has millions, hundreds of millions of these interns that are making decisions every millisecond, and potentially these decisions are incorrect, or these decisions leak PII, or these decisions are toxic, or they create liability for your customers. And being blind to that is super, super dangerous. I think from common surveys and the AI Infrastructure Alliance, which is a really cool group of organizations that are building tools for AI infrastructure, they recently did a survey, and half of the survey participants, which I believe was like a little over 2,000 people, said that the AI failures that they have observed in their organizations cost them 10 million and more. So AI can do great things. It could enable amazing automation. It could build beautiful and magical customer experiences. But when it does fail, it's very, very expensive.
Mm-hmm. Yeah, so expanding on your intern analogy, right? So, is it safe to say that observability is having a good protocol and a policy in place? You give them a handbook when they come in, and having checks and balances in place, right? So maybe have some code review before they check in something broken, right?
Love it.
It's almost like having constant monitoring of interns who are, in this case, that it is bound to happen. Anyone who has worked with LLMs, it is bound to happen. It's not a matter of if, it is about when is it going to happen, when is it going to do something stupid, right? So going back to the K example, it was shut down within 16 hours because it became a PR disaster for Microsoft, right? And it was, I would say that, from a technical standpoint, it was a beautiful thing, right? And no one dared to actually launch an LLM for many years after that, right? Because the technology was there, right? So it's a very interesting example. So there's one more question here by Jason. Many applications involve very complex chains of many models orchestrating tasks together, revising, expanding, generating all kinds of outputs that then result in a single output to a user. What are best practices for observability for complex chains? Complex question. Please go ahead. Yeah.
That's a great question. Thank you, Jason. So yes, ideally, just like with software, you want to enable observability at every level, because fundamentally, the next thing after you learn that something is not working well, you want to figure out why and how to fix it, right? So if you have a complex system, let's say you have a pipeline with multiple models where an output of a model becomes an input to another model, and then there's maybe potential ensembles, complex transformations, and then everything results in that user experience. In a complex system like that, of course, you want to kind of monitor at the most important parts, like what inputs are coming in, what outputs are coming out of the system. But if you just monitor, let's say, user experience, and you're noticing that, okay, the end user, my customer, does not accept or does not get any value from the outputs of this very complex and very expensive system, how do you tackle that? What do you do about it? And without having monitoring observability deeper in the stack, so around each particular model, and that is running in this complex system, potentially around the data quality that powers this complex system. If you do not have observability in those places, you can still operate it, and you would still get some signal from your users whether this is a valuable and good experience for them or not, but you wouldn't be able to debug effectively. And that's kind of one of the, I would say, most common, and I come from before, I started working as an engineer before ML was popular and widely used. So as an engineer, you have to be able to debug. Like, I worked at Amazon. Once you get a step 2 ticket, like, you're on the phone within 5 minutes. You are trying to resolve the issue within, I don't know, ideally 20 minutes, maybe an hour. Like, if you're not done with your step 2 ticket in an hour, you're probably already starting getting emails from like VPs. And if you're not done with it in a few hours, you're probably going to get that question, the famous question mark email. So debugging and fixing an issue is absolutely critical, and how fast you do it is basically the definition of how well your software works. So with large language models and any kind of machine learning model that's in your complex application, making sure that you have the observability to then use the observability signal to debug the model, to find out, okay, this particular model behaves exactly the same as it was behaving yesterday, but this particular model in my complex system is behaving differently. So you are able to pinpoint very quickly and to identify, where exactly the change has happened potentially, in combination with, where potentially a deployment has happened or not. But because these systems are non-deterministic, you want to monitor to, in addition to your visible software changes, you want to monitor for the behavior, and like in every single point. The best analogy I have for this is the best analogy I have for Y labs in the context of this complex systems is, think of Fitbits. So a Fitbit is something you put on your wrist, and it measures your vitals. So Y labs could be thought of as a Fitbit. So you have a Fitbit, you put it in various places. You have many Fitbits, and you put them in various places in your software system, in your complex multi-LLM or multi-model system, in all of the places where you need to understand whether that particular point in the system is healthy or not. So around model inputs, around model outputs, around kind of connections between multiple models, and of course at the very end to measure the user interactions, and of course at the very beginning to, if you're training, retraining, you might want to make sure that the data that's coming in for like automatic retraining is high quality and it's not going to derail your entire thing at the very beginning. So think of observability as Fitbits that you put in various places, and then the vitals from those Fitbits help you debug your application really quick.
Okay, that's great. So let's say we have crossed the hour boundary. So maybe last question from me. So I think of a tool for observability more. I think it's I think the work has meaning as well, right? So I mean, if you look at it, right? So you can if let's say if Y-Labs was around and it was sitting on top of Tay, maybe Tay would have still existed, right? Or maybe it would not have said things that it should not have said. I mean, so what keeps you excited about the work that you're doing?
So what keeps me excited, and that might be very personal to me, is I love the challenge, right? And I think observability is a very, very challenging problem. I have been working day and night on observability, nothing else but observability, for the past 6 years now. And I think the progress we have made, both as the community and the progress that we have made as the Y-Labs team, which is, again, 25 people working on observability for many, many years as the only problem they're trying to solve, is still pretty kind of in its infancy, because it's a very, very hard problem. Observability is something that is critical to the application. It is the very basic way of enabling how well you understand your application, but at the same time, it has to be done very efficiently. It cannot, observability signal that you're getting as an end user to operate your model cannot take a day to generate, right? It cannot cost more than your model inference. It could be too noisy. It could be not informative enough. There are just all of these things that come together in this observability problem, both engineering problems, user experience problems, machine learning problems, basic computer science problems that we're just beginning to solve. I think observability is something you could definitely dedicate your entire life's career to and make lots of progress, and there will be still problems unresolved. In addition to the fact that the whole space of machine learning and AI is changing so fast, right? Like in January of this year, we learned about ChatGPT. And that has completely changed how we do machine learning and AI and what we care about. Now we have foundation models, we have LLMs, we have various multi-model generative AI models and applications that are coming to exist, and observability has to catch up. So you can't just sit here and, well, you could just monitor your logistic regression models, but you'll become irrelevant very, very fast. So solving the problem of observability is as dynamic and as complex as building the models themselves, which is what I love. I love solving hard problems, and I love when the solutions make the world a little bit better. So that's the space that I'm dedicating my time to.
Okay. Thanks a lot, Alyssa, for your time. And maybe we should catch up again in coming months on a different topic. Okay. Thank you
Absolutely.
so much. And thanks everyone who's attending. Maybe next week. Okay.
Excellent. Thank you, Raja. This was really, really fun. And thanks everyone who asked questions.